Welcome to The Explainer. Today, we're going to do a masterclass on how to absolutely ace your chemistry exam. And we're going to do it by learning to think like an examiner. We'll be deconstructing a high-value question, using the official mark scheme to see exactly what you need to write to get every single mark.
All right, here's our game plan. We're going to take exam question 08 and break it down piece by piece. We'll start with the concepts, then hit the equations and the big calculations. And we'll finish up with the key takeaways that you can use to really maximize your score on any question. So, first up, we're putting the exam paper and the official mark scheme right next to each other. This, right here, is the key to unlocking the secrets of a perfect score. This is how we're going to do it. On the left, you've got the exam question, what you actually see on the day, and on the right, you've got the mark scheme, the document that tells the examiner exactly what to award points for. Understanding this connection is, well, it's everything. Okay, let's get into our first concept question and see how this all works in practice. You'll see how a single, simple mark can be won or lost based on some very, very precise wording. So the question asks why the reaction is an oxidation. Now, that seems pretty straightforward, right? But the examiner isn't looking for just any old explanation. They want a very specific technical definition to give you that mark. Before we even peek at the mark scheme, let's just remember the absolute fundamental definition. You've probably heard of oil rig, right? Oxidation is loss, reduction is gain. We are laser focused on that loss of electrons bit. And there you have it. You can see it plain as day. The mark scheme shows the only acceptable answer. It is not enough to just define oxidation in general. You must state that sodium atoms are the ones that lose electrons. That's how you get the mark. Now, what's really interesting here is this little note from the examiner. Even though the word is oxidation, which might make you think of oxygen, if you mention it here, you get 0 marks. They are specifically testing your understanding of oxidation as electron transfer, period. Okay, next up, we're tackling the half equation. This is another one of those one-mark questions where a tiny, almost insignificant-looking detail makes all the difference between getting the point and getting nothing. So here's the question itself. You're given the beginning of the equation, Na with an arrow. Your job is to fill in the blanks and show what happens when that neutral sodium atom becomes an ion. And there it is. That's the complete, correct answer that gets you the mark. A sodium atom, Na, becomes a sodium ion, Na+, because it has lost 1 electron, which we write as E-. Now this is the crucial point, and it comes straight from the mark scheme. Do not accept E for E negative. Just writing the letter E is not good enough. You absolutely must include the negative superscript to show it's a negatively charged electron. Every single symbol matters. All right, time for the big one. This is the 4-mark calculation to figure out the limiting reactant, and this is where showing your work is completely non-negotiable. So the question gives you all the data you could possibly need. 40 kilograms of titanium chloride, 20 kilograms of sodium. It even gives you the relative atomic masses. But crucially, look at what it says. You must show you're working. That's because you get marks for the method, not just for pulling the right answer out of a hat. So let's break down exactly how you earn those 4 marks. You get 1 mark just for calculating the MR of TiCl4. You get a 2nd mark for working out the moles of sodium, and a 3rd for the moles of TiCl4. Then, that final crucial mark is for using the 4-to-1 ratio from the equation. You had 211 moles of TiCl4, which needs 844 moles of sodium. But since you actually have 870 moles, you've got more than enough. And that right there proves that TiCl4 is the limiting reactant. All right, let's lock in the final marks on question 08. This is a classic 2-mark percentage yield calculation, but they've given it a little bit of a twist. So this is what you might call a reverse percentage yields question. Usually you're calculating the percentage, but here they give it to you and ask you to work backwards to find out the actual mass of titanium that was produced. The question straight up tells you that the percentage yield was 92.3%, and you're also told that the theoretical maximum mass, the most you could possibly make, was 13.5 kilograms. To solve this, we just start with our standard formula. The key is to rearrange it so you're solving for the actual yield. So you're going to multiply the percentage yield by the theoretical yield, and then divide that whole thing by 100. You plug in the numbers, and you get your final answer, 12.46 kilograms. You know, it's interesting, the mark scheme actually says that just writing this correct answer gets you both marks. But like we saw before, it is always, always safer to show your method. So, after this really deep dive into just one question and its mark scheme, what are the crucial lessons? What can we take away from this that we can apply to the entire exam?
These are really the golden rules. 1, use the exact scientific term, like loss of electrons, not something vague. 2, show every single step in your calculations. You get marks for your method. 3, pay attention to those tiny details, like the little charge on an electron. 4, answer the precise question they asked, not the one you wish they'd asked. And finally, 5, understand that in these big multi-mark questions, each step you show earns its own credit. By looking at the mark scheme, you're no longer just guessing what the examiner wants. You're learning the rules of the game. You stop just answering questions. You start actively and strategically earning every single mark that's available.